probably the only time that I'll use a PowerPoint during the year. I'm not a big fan of PowerPoint lessons. So we're starting into chapter 1.1. So why do we need to know this? This is vocabulary. These 8 vocabulary words that we're going to talk about today, we're going to be using still next May. So these are vocabulary that we're going to use for the entire year in geometry. We're going to use all this important information sets a foundation for what we're doing. That's what we call the foundation of geometry. So these are our standards, our mathematical standards. We're studying our specific standard has to do with geometry, shape, dimension, and geometric relationships. In chapter 1, we're talking about objects in the plane and how we can transform them, how we can describe them, how we can talk about them with math is really what we're doing in this first chapter. How can we use math to describe these things? For today, our important ideas are what we're going to talk about is the undefined terms and some definitions, some basic definitions. And by the end, the purpose of this lesson is we're going to understand, we're going to know what the undefined terms are, and we'll get to them in more detail, but we're going to talk about points, lines, planes, and we're also going to talk about segments, rays, angles, collinear, and coplanar are the ones we're going to emphasize. We'll define each of those in just a little bit. So this is what we're studying. So a little bit of history. What we're starting now is called Euclidean Geometry, and it's named after a gentleman who lived in ancient Greece at about 300 BC. His name was Euclid, and Euclid really set the foundation for almost all of the mathematics that we study. He wrote a book. It's a volume of books called The Elements, and it was really important because it was the first time that someone had systematically put together these ideas in math and applied logic to mathematical ideas. So he developed this system of using logic to figure out how math would have to work, and he applied it mainly to geometry. He did a lot of work, but the part that we're interested in has to do with geometry. And Euclidean geometry is really the only type of geometry we knew until the 19th century, until almost modern times. And since then, we've discovered new kinds of geometry. What Euclid did was start with some basic ideas called axioms. Start with these basic ideas and use logic to build on these axioms. And that was really the power of what Euclid did, was start with these ideas and build them with logic. It was the first time that someone had done that in a very systematic way. And we'll talk about Euclid and different kinds of geometry as we go through the semester. So our definition of geometry, this doesn't go on your sheet. I just want you to know what we're talking about. So geometry has to do with the properties, measurements, and relationships of these things: points, lines, angles, surfaces, and solids. So that's what we're going to be talking about, using math to talk about these things. All right. Our first definition that goes in your first box in your prayer model is point. That goes right in the middle there. Point. An important characteristic, make sure you put this in the important characteristic for point, is it is one of the undefined terms. And the reason it's undefined is there's no such thing as an actual physical point. It's an idea. It's a mathematical idea. This idea that we have, we can work with it, but a point doesn't actually exist out in space somewhere. We can give examples that are kind of like points, but it's not actually the mathematical point. What's that? A point is one of the undefined terms, yes. Our technical definition is a point is something that has no size. Something that has absolutely no size. We usually show a point by a dot. So when you're drawing, you could just draw a dot. We name it with a capital letter. So this drawing would be point B. So you can put that in your drawing. You can put this in your important characteristics that we name it with a capital letter. And the way we would read this, if we were reading this, is point B. So we're talking about this point B. An example, the way we usually think of a point would be the tip of a super sharp pencil. Really, really, really tiny. Or a tiny, tiny little speck of dust would be an example of a point. We talk about points on the map. That would be another example of how we think. A non-example would be something with a bigger size. My coffee cup would be a non-example of a point. A car. Something that's big, that has a lot of size, would be a non-example. And I'm sure you can think of others. So our point, one of the undefined terms, it's something that has absolutely no size. Are we good with points? All right. Our next undefined term is a line. So make sure you put your word in the middle, your line. An important characteristic is it's one of the undefined terms. The line goes in the middle. One of the undefined terms is an important characteristic. Our technical definition. Undefined term just means that it doesn't, there's no real example of a line as we think of it. So we have an idea of what it is, but there's no actual example. They really exist only in our minds. Our technical definition. A line is something with no thickness and is perfectly straight and goes on forever in both directions. Cassie, you with us? This is important. You need to write this down. So our technical definition, no thickness, it's perfectly straight and goes on forever in both directions. So we could draw a picture of a line. Normally you see a line that looks like this. And I'll put a couple of points on my line. It takes 2 points to make a line. So any 2 points are going to be on a line. That would be an important characteristic. And we name a line with 2 points on the line with the double-headed arrows over the 2 capital letters. So let me write this in so you can see this. I would name this line that I drew line AB, and I put arrows over the top. The arrows show that it goes on forever in both directions. Sometimes you'll see a line drawn like this, and it'll have a lowercase letter. In that case, we could name it line M. So this is line AB. This is line M. This line, we name line AB. This line, we would just name line M. But we always show a line with an arrow on both ends. That shows that it goes on forever in both directions. So an example of a line, the way we think of a line, a long, 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 thin thread that's stretched out basically forever, going on in both directions. Maybe a long, straight railroad track that goes on in both directions. That would be an example of how we think of a line. Non-example, something curved is not a line. Something with a shape isn't a line. My pencil would be a non-example of a line because it stops, it doesn't keep going. And I'm sure you can think of others. And it's important that we get this, how we name these things, because part of what we're doing with this chapter is make sure we understand the notation. So you'll be asked to name something using proper notation. And that would be naming a line with 2 points and a double arrow over the top. So part of what we're doing is learning this notation, how we write their names. Are we good with lines? Are we ready to go to our next undefined term? Not yet? Okay, we good? All right, our next, yes?
What would be the technical?
Something with no thickness and goes perfectly straight forever in both directions. All right, our next undefined term is a plane. So this is our third undefined term, is plane. The plane goes in the middle. Undefined term is one of our important characteristics.
Are there any defined terms?
I'm sorry?
Are there any defined terms?
Yes, we only have three. We're only going to talk about 3 undefined terms. The rest we'll define. But we have to use point, line, and plane to define our other terms. So we have to start somewhere. Our technical definition is something with no thickness and it extends infinitely in all directions on a flat surface. So these two together make our technical definition. We show a parallelogram, or we show a plane as a parallelogram. So we draw a plane. If we're drawing a picture of a plane, let me make that a little thinner. We would draw a parallelogram. So a parallelogram is a portion of our plane. And we name it by 3 points. That are on the plane, not on the same line. So this would be, we would name this plane M, N, O, and we have to use the word plane to know that we're talking about plane. We could use the symbol, the parallelogram, or if it has a script letter, a cursive letter written in the corner, we could call this plane R. Let me make a better script R. So we could call this plane R. R is not a point on the plane. M, N, and O are points on the plane. So all 3 of these are ways that we could name this plane. And an example, the way we think of a plane would be a wall or the whiteboard up here. That would be an example of how we think of a plane, a big flat surface. A non-example would be something curved. A line or a point are non-examples of planes. Lines and points are not planes. The plane has to be something that's flat and extends in all directions. Questions on planes? All right, are we ready for our next definition? So those three, point, line, and plane, are our undefined terms. The rest are, those are the only three undefined terms. It's an undefined term. All right. What is the correct name for this plane? A, B, or C? Who thinks it's A, plane F? Nobody goes for A? Who thinks it's B, plane F-U-N? Who thinks it's plane C? Or I'm sorry, just F-U-N. B is correct. We name it, we say it's a plane, and we use 3 points that are on the plane that are not on the same line. Anybody have an idea of why we say the 3 points on our plane can't be on the same line? What's that? So let's say I have a line drawn on this folder, 3 points on the line, and this folder is my plane. If I rotate the folder on that line, are those 3 points still on the line? But are they in a different plane now? So I can rotate the folder around that line and have lots and lots of different planes. So that's why we can't have 3 points on the line. That line acts like an axis that I can rotate around. All right. Our next, is this the proper name for, let me get a different color up here. Is this the proper name for line DQ? Eventually? The cursive is okay, but we're talking about a line. What do we need for a line?
Oh.
We need arrows. There we go. We need arrows. That would be the proper name for line DQ. We need arrows. And the arrows are important because there's something else that we'll name without arrows. All right, our next two definitions. The first one is collinear. So collinear is going to go in your box. And your technical definition is just all points that are on the same line. Co just means together. Linear means line, so collinear means together on a line. So if we drew a picture, all these points are collinear. They're all on the same line. An important fact or characteristic of collinear is that if we have any 2 points, they will be on a line. Any 2 points are collinear. We can make a line through 2 points. So an example of collinear would be any points that are on the same line. If we talked about numbers on a number line. Numbers on a number line would be collinear. A non-example would be something that's curved. Points that aren't on the same line. So points on a plane are not necessarily collinear. So if they're not on the same line, they are not collinear. Our next term, coplanar. So that's going to go in a new box. Our technical definition, all points in the same plane. So co just means together, and planar means plane. They're together on a plane. if I drew a picture of that, here are my points that are coplanar. Those 5 points are coplanar.
What do you mean any 3 points are coplanar?
I'll talk about that in just a second. So this could be a picture, an example of coplanar. These magnets on my whiteboard, they're all on the surface of the whiteboard. So those points where the magnets are on the board would be an example of coplanar. A non-example, again, a curved surface. Something on the surface of this table here in the front, and then something on the ceiling are not coplanar. They're not in the same flat surface. So the ceiling, anything that's on the ceiling would be coplanar, but something that's on the ceiling isn't coplanar with something that's on the table. So the surface of the ceiling is not coplanar with the table. Now, an important factor characteristic of coplanar is any 3 points make a plane. And what I mean by that is if we take 3 points, any 3 points, no matter how we arrange them, we can always find a plane through those 3 points. And the example that I'm going to use all year long is the example of a tripod. The reason they make tripods with 3 legs is no matter how you set up those legs, if you set it down, the tripod, those 3 legs will sit on the ground. Now your camera might be tilted, but you can get those 3 legs to sit on the ground. So those 3 points, the ends of the legs of a tripod, are always going to be coplanar. That's why they make tripods with 3 legs rather than with 4. Because if you set the 4th leg wrong, your tripod is going to wobble. But no matter how you set up your legs of your tripod, you set it on the ground, those 3 points are going to be on the ground. Doesn't mean your tripod's going to be straight, but those 3 points will always set on the ground. So that's what I mean by 3 points are always coplanar. Questions on collinear or coplanar? Co just means together. Linear on a line, plane, planar on a plane. All right, our next definition, a line segment. So our term, you can write line segment, or often we just write the word segment. So our technical definition is a part of a line that begins at one point and ends at another. So usually we write a segment, we draw a segment like this. So it's just a piece of a line. We could also draw our segment and show the line, but the part between AB, between points A and points B, are the segment. So this part in here is the segment. The points are called the endpoints. So I'm going to draw it again down here. So the points at the end of the segment are called the endpoints. So that would be an important characteristic. And another important characteristic is we name it with its endpoints. With a straight bar over the capital letters. So the straight bar without arrows means that we have a segment. We have a piece of line. So the arrows tell us that it keeps going. If we don't have the arrows, it means it stops. So that's what we have here. So an example of a segment, a line segment, might be my pencil, because it stops at both ends. A meter stick, a driveway, starts and stops at the end, so that could be an example. part of this microphone stand could be a segment. Something that does that ends, that has an end, one end and another end. A non-example, something that's curved, something that does go on forever. A line would be a non-example of a segment. A plane would be a non-example of a segment because it goes in multiple directions. Are we good with segments or line segments? Okay. Our next term is array. So that's going to go in your middle box, array. Array is a part of a line that starts at one point and goes infinitely in one direction. So we have something like this. So an important characteristic, the point where the array starts is the end point. And we name it using the end point and one other point on the array. So the end point is M, the other point is R. And we put an arrow over the two capital letters. And the end point has to be over, the end of the arrow has to be over the point that's the end point of the array. So there's MR. And my end point matches up with point M here. I could also write this array RM, but I'd have to turn the arrow around. So the end point matches up with the end point here. Either one of these would be a way we could name that array. So an example, the way we usually think of array would be maybe a flashlight beam. So our light starts at the flashlight and extends out forever. Maybe our car driving on a road, so we start here and we keep driving in a straight line, so that we could kind of think of that as array. If we throw a ball, if we think of the ball traveling in a straight line, the ball starts at our hand and goes straight. So we could think of that as array. Non-example of array, again, something that's curved, something that does stop. A line is a non-example of array. A point is a non-example of array. The array has to be something that starts at a point and goes forever in only one direction. Questions on array? And how we name them? So this would be a good drawing for array. Factor characteristic. You could say that you could talk about how it's named. That the point here is called the end point. Those are important facts or characteristics. All right, so we want to name this array. How do we name this array? Evangeline? The arrow pointing to the R or to the B? Perfect. RB, the two capital letters, those are the points. We have the end point R and another point B. And the end point of our drawing matches up with the end point on our array. So this would be one way. What's another way we could name the array? What do you think, Preston?
You could do DR and have the arrow pointing to the left.
Arrow go the opposite direction. That would work as well. The endpoint matches up with the endpoint of my ray. The way I've written it matches up with the way it's drawn. So either of those are good ways to name this ray. All right, angle is our next term. So angle goes in the box. Our technical definition: it's a figure made by two rays with a common endpoint. So our drawing. So my two rays, it has a common endpoint. An important factor characteristic is that endpoint is called the vertex. That's the vertex of the angle. I'm going to draw another one down here. Important factor characteristic: rays are the sides of the angle. Yes. Yes. Rays are the sides of the angles. So each side is a ray. Another important factor characteristic: the part between the rays is called the interior of the angle. The exterior is everything out here. So everything outside the two rays is the exterior of the angle. We name angles three different ways. So let me draw another angle down here. We can name it with an angle bracket and 3 points. The vertex has to be in the middle. So I can name this angle A, B, C. The vertex has to be in the middle. I can also call this angle B with the angle bracket. And if it has a number written inside here, like so, I could call this angle 2 if it has a number written inside. So this is angle 2. We have to be careful with this middle one for naming an angle. If we have an angle that's drawn like so, so we have more than one angle here, and this is point B. If we use this middle way to name this angle, angle B, we could be talking about a lot of different angles. So we can only use the middle one. We can only use the letter that's at the vertex when there's no confusion as about which angle we're talking about. So we can't use angle B to name any of these angles, because we would be confused about which angle we were talking about. So this one works only if there's no confusion about what angle we're talking about. So an example of an angle would be maybe the corner of the room. The edge of this board makes an angle. The arm of this microphone is making an angle. A non-example, two things that are curved. So if we have two things that are joined together like this, that would be a non-example because the sides aren't raised. We can't have an angle that's made of two rays that aren't connected, so that would be a non-example. A point is a non-example of a ray. A segment is a non-example of a ray. A plane is a non-example of a ray. A ray has to have an angle. All of those are non-examples of angles. An angle has to have two rays as sides, and they have to meet at a common endpoint. And with each of these, it's important to come up with your own definition in your own words. How you think about these things, how it helps you to remember them. All right, so here's our angle quiz. We want to name this angle 3 different ways. So how can I name it? Angela, can you give us one way? Can we say ABC? There we go, BAC. The vertex has to be in the middle, and we have to use our angle sign. What's another way we can name it?
The angle at A.
Angle A works. There's no confusion. And there's one more way. Angle 4. Because we have this number in here, we can name it angle 4. Any of those 3 ways works. Is there another way we could write this? CAB. As long as the vertex is in the middle, it doesn't matter which order I put the other letters. The vertex is in the middle. So those are our 3 ways. 3 ways, actually we came up with 4 to name that angle. Question? Yes. All right. I think that's everything. Yes. So, I know that was a lot of vocabulary. Let me stop my microphone. We won't have as much after this, but these are important terms that we're going to be using for the rest of the year. And so your reward is that we do not have homework tonight.